Hello. In this video we'll do the practice for the derivatives of trigonometric functions. The first function we would like to find derivative of is x cubed times cosine of pi x. So we would like to find the derivative of this function. Let's try to see which rule we can apply. If we read it aloud, we can hear that it says x cubed times cosine of pi x. So since we heard the word times, we would have to use the product rule. The product rule says take x cubed, calculate derivative, multiply by the cosine of pi x plus x cubed times the derivative of cosine of pi x. Then we tried to see where we still have primes. We have a prime over here and we have a prime over here. So first we need to find derivative of x cubed. According to the power rule, x cubed derivative would be 3 times x to the 2 times cosine of pi x plus x cubed times the derivative of cosine of pi x. Unfortunately, this cosine has pi x inside of it, so we can't just apply the rule for cosine. We would have to use the chain rule. And here we see that the last step in calculation cosine of pi x would be taking cosine. So cosine is the outside function and pi x is the inside function. The chain rule says take derivative of the outside function first. So we'll have derivative of cosine, which is negative sine of the inside function, which is pi x. Then the chain rule says multiply by the derivative of the inside function, which is pi x derivative. We're going through the expression, we're trying to see where we still have primes. There is no prime except in this pi x expression. So finally we calculate this derivative to get 3x squared times cosine of pi x plus, this plus becomes a minus because we have a minus in front of sine, so we put a minus over here, and we have x cubed times sine of pi x times the derivative of pi x. And pi is a constant and derivative of x is 1, so we get pi. And for all practice purposes, this would be good enough for us. So we'll stop over here. The next derivative that we're going to do is derivative of tangent of square root of 1 minus 2x. We want to calculate derivative of g, which is derivative of tangent of square root of 1 minus 2x. If we would try to plug in the value for x, we would multiply it by 2, we would subtract it from 1, we would take a square root, and then we would take a tangent. So we take in tangent at the last moment, so this would be the outside function, and this would be inside function for the chain rule. Chain rule says take derivative of the outside function first, and derivative of tangent is secant squared. So we'll have secant squared of the square root of 1 minus 2x times the derivative of square root of 1 minus 2x. So there is no prime inside of the secant. This is the only expression with the prime. And if we would try to plug in x, we would multiply it by 2, we would subtract it from 1, and then we would take a square root. So taking the square root is the last thing we do, therefore this is an outside function, and 1 minus 2x is the inside function. So we keep going, we rewrite secant squared times square root of 1 minus 2x times the derivative of the square root. We know the derivative of the square root is 1 over 2 square root of 1 minus 2x, and chain rule tells us multiply by the derivative of the inside function, which is 1 minus 2x derivative. We're looking through, there is only one part that has prime in it, which is this part. Therefore, we rewrite everything else as it is, and we're going to take derivative of 1 minus 2x at the end. Derivative of 1 is 0. Derivative of negative 2x is negative 2. And for all practice purposes, this is a good place to stop for us. Maybe if we want to be a little bit more savvy, we can divide by this 2 and write it as negative secant squared of the square root of 1 minus 2x divided by square root of 1 minus 2x. The next example that we're going to do is sine of cosine of x. This is kind of a famous example. Pretty much every book has it. Probably should have been written as some f of x equal to it. And we would like to find derivative of this sine of cosine of x. So let's try to figure out how we can apply chain rule over here. If we would plug in x, we would calculate cosine first, then we would calculate sine, and therefore sine would be the outside function and cosine would be the inside function. The chain rule tells us to find derivative of sine first, and we know derivative of sine is cosine of x times the derivative of the inside function, which is cosine. Finally, we have cosine of x times the derivative of cosine, which is negative sine. And so we're done with this exercise. The last example for today is cosecant of 1 plus x squared. So we'll try to find derivative of this function, which is derivative of cosecant of 1 plus x squared. One more time we have to apply chain rule. If we would plug in x, we would take x, we would square it, we would add 1, we would take cosecant. So cosecant is outside and 1 plus x squared is the inside function. So derivative of cosecant is negative cotangent of x times negative cotangent of 1 plus x squared times cosecant of 1 plus x squared. Times the derivative of the inside function, which is 1 plus x squared derivative. So this was the derivative of the outside, and this was the derivative of the inside. Finally, our answer is negative cotangent 1 plus x squared cosecant of 1 plus x squared times the derivative of 1 plus x squared. Derivative of 1 is 0, derivative of x squared is 2x. And that concludes this little practice for derivatives of trig functions. I'll see you in the next lecture.